Hello and welcome everyone. My name is Dhananjay Patankar and I'm a CCNA, CCNP and security trainer. I got almost 20 years experience. I'm preparing this small demo so that it will give you some idea about the trainer's style of teaching before you actually join the course. And today we'll take up a very interesting and an important topic from CCNA point of view, not only from the exam and knowledge point of view, but also in your real life scenarios in the job. It will be very useful in CCNP as well as CCI. So let's take a small topic. Just to give you a demo, let us take up IP ACLs, right? Access control list, right? And we use this IP ACLs to filter unwanted packets, right? So we are going to configure IP ACLs on Cisco routers. I will give you an idea about how to configure it on the Cisco routers, how to verify it, how to troubleshoot it. So IP ACLs, access control list, right? Now there are certain types of IP ACLs, namely standard access control list, right? I'll explain you all the things in detail as we proceed ahead. And we have extended access control list, right? Standard as well as extended. Whatever is the limitation of standard access control list, to overcome those limitations, they came out with extended access control list. We also have named access control list, but named access control list is not a separate category. You have to specify whether you want to use a standard named access control list or an extended named access control list, right? So whatever the limitation of named access control list, finally we have sequential access control list, right? Sequential. Again, in the sequential, we have to specify whether you want to use a standard access sequential or extended sequential, right? Categories are only namely two, standard and extended. So whatever the limitations of the first one, like standard, extended was discovered, something like this. Now in the named access controls, we are going to use names instead of numbers, right? Standard, extended, we are going to use numbers, right? So if you configure your standard access control list in the command, when you start configuring your routers, right? We'll do it on Cisco routers. You can use any of these numbers, 1 to 99, right? In case of extended, we can use 100 to 199. Any number is okay, right? Nothing is better, nothing is worst. And later on, they came out with IP standard expanded range, which is from 1300 to 1999. And in the case of IP expanded access control list, they came out with these numbers, 2000 to 2699. So you can use any number. For the sake of simplicity, I'll just use 1 in the case of standard and 100 in the case of extended. And in the named access controls, as I said, we are not going to use numbers, but we'll use some name. We'll give a name to the access controls, right? Okay. Now let's proceed. Okay, few more things about standard access controls. Whenever you configure a standard access controls, always try and place it near the destination. This is not a rule. This is only a recommendation, right? Destination. And whenever you configure extended access controls, try and place it nearer the source. Is that okay? And in standard access control list, whenever a packet comes on the router, it checks only the source IP address of the incoming packet. Remember all these things. You might be asked in the interview, right? Exam point also, you'll get one simulation 100% sure, right, in the exam. So you'll have to practically configure it. And in the case of external access control is, whenever a packet comes on the router, it is going to check 4 things. What are they? It's going to check the source IP address, as well as the destination IP address, as well as protocol, as well as destination port number, right? Port number. Only after that, it's going to either permit or deny your packet. Now, as we go ahead, I'll keep on explaining a lot of things. Top to down processing takes place on one router's one interface. You can place only one inbound access control list for IP and one outbound access control list for IP. For IPX also, on every router's single interface, you can place only one access control list for IP inbound and IP outbound. Likewise, for IPX inbound, only one, and IPX outbound, only one. Likewise, for AppleTalk, only one access control list inbound and only one outbound on a single router's interface. Implicit deny any is also there. I'll explain you. Now, whatever commands we are going to give, they will be explicit, permit, or deny statements. Now, what are these access control lists? There are several permit or deny statements that we are going to configure on our routers, right? So whenever a packet comes, it will check the access controls on the interface and whatever you have configured from the global mode. Accordingly, it will either permit that packet or it will deny that packet. Now, I think let's proceed with a demo, right? Let me open my packet tracer and quickly let's come up with a small topology, build a small topology. So I'll take one router here. And in the interest of time, I could have taken more routers, but I'll just take 2 here. That should give us a fair idea about how to configure and how to verify it. So I've taken 2 routers, maybe a switch here as well. So we have 2 LANs here. In between, we got 2 routers. Okay, so I'll now start connecting the router to the switch, right? The PC to the switch. Again, gigabit 0/0/0 port goes towards the LAN in both the cases. So I remember that. That's easy for me. So no confusion. You can configure, you can connect any port anywhere, not an issue. So this is the way I remember. Gigabit 0/0/0 has gone on the LAN on both the routers. And in between the 2 routers, we have gigabit 0/0/1, right? Now, let us quickly go on the router and start configuring it. We don't want to get up into the setup, right? So configure terminal. Let's give a host name of R1 and some IP address interface gigabit 0/0/0 towards the LAN. Let's enable it, no shut, right? No shut, and let's give an IP address. Let us say we'll keep on the left LAN 10 dot something. In between the 2 routers, let's say 20 dot something. And on the LAN towards the right of, let's say router R2, we'll have it 30 dot something, right? So 10.1.1.1, we'll keep it very simple. And let's say we got 254 hosts. We have done IP addressing subnetting. So up to 254 hosts, that's it. And we'll configure the second port also, gigabit 0/0/1. Again, up arrow, we'll give no shut command to enable it. And an IP address of, let us say 20.1.1.1 and a subnet mask of, let us say 252, right? That will be enough for 2 IP addresses in between 2 routers. We are done with this. Let us configure some routing protocol also, right? Let us say router OSPF1 And we have done OSPF. Yeah. 10.1 dot, sorry. We can give 1.1.1 and wildcard mask of all zeros. And here we'll keep everything in area 0, right? Again, we'll configure 20.1.1.1, right? Do show IP protocols. Okay. So routing for networks. Great. Now, let's move on to R2. We'll name this first one, second router as R2 to begin with. Setup no. Enable configure terminal host name R2 interface gigabit 0/0/1. The one facing a router R1 on the left, right? Enable it by giving no shut command, and we'll give an IP address of, let us say, 20.1.1.2. Remember the subnet mask in between the two routers? 252. Yeah, so no wastage. And up arrow. We'll take gigabit 0/0/0 now. Up arrow, no shut. And an IP address of, let us say, 30.1.1.1. And of course, it's a LAN. So let's presume that the subnet mask, we require 254 hosts. So we'll keep it /24. This will be, let us say, 30.1.1.1. Is that okay, guys? 10 dot, 20 dot, 30 dot. Good. And now what? Let's configure some routing protocol. We configure router OSPF, which is a link set routing protocol. We have done it. And network is going to be 20.1.1.2. Yeah. Did we give IP address? Yes. 21 and 2. And wildcard mask, all zeros. And we can give area 0. And one more IP address. What is that? 30.1.1.1. Fair enough. That's it. Do show IP out. See that adjacency has come up. So we have discovered. We yet to discover. See that we have discovered OSPF. We have discovered 10.1.0 through OSPF. Okay. Now let's get to our host here. This is 10. Let's give an IP address to this guy. Yeah. We'll give it as what? 10.1.1. Let us say 2. Subnet mask /24 255.0 and default gateway 10.1.1. Is that okay, guys? Similarly, let's go on this PC here and let us give an IP address of, let us say, 31.1.2. Simple. 31.1.2. Subnet mask 255.255.255.0 and default gateway will be 30.1.1.1. Is that okay? Now, this guy is what? 31.1.2, correct? Now let's try and ping from this PC. Can we ping 31.1.2? Yeah. Ping, as we know, comes on layer 3, uses ICMP protocol, is used to, yeah, find out connectivity between two devices, right? 30.1.1.2. So do we have connectivity? Yes or no? Should ping. That's it. So everything working. First packet, it's dropped. You know why, right? Because it has to make table in the entry in the ARP table. Okay, fine. So now let's configure a sample sake standard access controls, right? Now this guy should not be able to ping this guy, right? Now in standard, what happens is it permits or denies entire protocol suite, which means what? If you say permit, this guy can ping, telnet, file transfer, trace route, do everything, right? Left host to right host. Let us say just an example. But if you deny, it won't be able to do anything, right? No ping, no telnet, no file transfer, nothing. In case you want this guy to only ping but not telnet into that other device, or vice versa. You want this host to only telnet, right, but not ping, anything like this, if and buts. Then we can go in for extended access controllers, because in the extended access controllers, permits or denies specific protocols, right, like TCP, UDP. So let me give you a small demo of. So we saw that this PC could ping this PC. Now, let us say the source is on the left and the destination is on the right, right? So the packet is going to move from left to right, right? From the left host to the right host. Now, if you want to configure standard, where do we place it? Standard access control is always try and place it near the destination. So destination is here. So let's go. There could have been n number of routers in between. So let us go on this router R2, and from the global mode, let's start configuring access controllers. What is the command? Access list 1, right? See question mark. If you don't understand, don't remember, give a question mark. Take my help, right? You can ask me anytime. Access 1, what do you say? Permit or deny? Let us say I want to deny it. If you want to say permit, by the way, everything is permitted without access controls, right? Anybody can access anybody, ping, telnet, anything and everything. So now we are going to deny it. We don't want the left host to either ping or telnet the right host. So now, again, question mark. Deny whom? It can be a whole network, 10.000. It can be a subnet, 10.1.1.0 with the wildcard mask, right? In access controls, we are going to use wildcard mask. And you all know what a wildcard mask is. 0 means check, 1 means ignore, correct? So access 1, deny whom? Let us say I just want only this host, should not be able to access that host. What's the IP address of that host, right? It is 10.1.1.2. Remember that? 2. That's it. And now let's get under the interface. Which interface? The interface which is nearer the destination, which is that it is this one, gigabit 0/0/0, right? So we go below that interface and place the access control there. 0/0/0. And what's the command? IP access group. What number we use here? 1. So we'll give 1 here. If you said 2 there, you'll have to give 2 here. And if you give the wrong direction, your access controllers will fail, right? So in or out, by default, it is out, right? So now R2 packet is going to come from the left PC to R1. There's no access controllers on R1. So it will go to R2 because we have routing configured now. It will enter this port, gigabit 0/0/1, and it doesn't find any access controllers, right? Right, access is under that port. So it will look at the routing table. It will do a routing table lookup, and it will say, okay, the packet needs to be sent out from gigabit 0/0/0. So it will switch the packet from interface 001 to interface 000. And before sending out, it will check, the router is going to check whether any access controllers has been placed there. Yes. Is it inbound or outbound? It is outbound. See that? So now, before sending it out, it is going to check the access controllers. What does it say? IP access group 1. What does one access list say? It says deny any packet coming from this source IP address, right? So now we have done it. How do you verify that? Verify, do show access list or do show IP access list. See this? The sequence number 10 has automatically come, right? It begins with 10 and it automatically increments by default, it increments by 10 only, right? So we are given this access control deny, but there's one more thing, very important thing. You always have to say, you always have to give one permit statement, otherwise routing will stop, right? So now we forgot to give the permit statement. How do we give it? How can we configure it? Now, again, let us say IP access list standard. Now this is sort of your sequential access control, right? So this demo is also will be covered here. Now what? 1, right? IP standard access control is 1, right? Now look, it has come under standard named access controllers. Though this is not named, it's sequential. So now we have to begin the command with permit or deny statement. So we'll say permit any, right? We'll say sequence number 20 permit any. After this, again as a third statement, which will be invisible, Cisco, these are explicit deny or permit statements, but Cisco automatically brings a implicit deny any statement at the end of it, which is not visible in the show run command or any other command, right? Show access list. Now look, we are sequence number 10, we are sequence number 20, right? Now, that's it. If you want to save it, what is the command? Do copy, run, start, or do write, right? Same thing. Now let's go and try and ping the other host 3112 from this guy. Yeah, will it ping? See that? It doesn't ping. Now what's happening actually? When this guy is pinging this guy, the packet is coming first to its default gateway because this guy knows I am in 10 and the destination is 30. So I need to send it to my default gateway, which is 10.1.1.1. Remember that we have configured it. Now, when the packet has come here, router will look at the destination. It is what? 30.1.1.2. It will do a routing table lookup and forward from this particular port, right? So the packet will reach here. There is no access control is placed here. So it will do a routing table lookup and decide that, okay, the packet needs to be sent or dropped out from this port. So the right ones will be forwarded from this port, but any packet which the access control is asking the router to drop it, deny it will be dropped from this port and it will not be forwarded. Correct? So now what happens is it has come here, packet, it does a routing table lookup and it will switch the packet from this interfaces buffer to this interfaces buffer. Right? Now before sending out, it is going to look at its commands, right? What are the commands? Let's have a show run command here, right? Verify them. Look, this is our gigabit 00 port. And we have this command given under the interface, right? So now, IP access group 1 out. What does 1 stand for? So standard IP, right? And the router knows that the IS knows 1 means standard, means only to check the source IP address. So if the packet is coming from 10.1.1.2, it will do what? It will deny that packet. Your purpose is solved, right? But if the packet comes from anybody else, it will forward the packet, right? So let's take one more PC here quickly and just connect it. And we'll give it an IP address of 30.11. Yeah, 30.113. Okay, quickly. 30.1.1.3. And the subnet mask of 3.255 has to be same, right? 0. And default it will be again 10.1.1.1. Now, if this guy pings this guy, it should ping, correct? Because we have denied only 10.1.1.2. Now let me try and ping. .1.1.2. Will it ping? It has to ping, right? Because we didn't use the network or the subnet. We said only one particular host. And after that, we gave that permit statement. Had we not given the permit statement, it would not have pinged. Now, why is it timing out? 31.2. Any problems? Let's check the default gateway. What is it? 31.3. Ah, see that? This IP address is not 30 man, it is 10 dot. Right. So look, by chance, troubleshooting is also taken care of. Yeah. Let's try pinging. See that it's pinging. Yes, guys. So you got a fair idea about access control list? Yeah. Now, let me quickly show you some slides here. One sec, guys. And here comes your access control list, right? So remember, this is a very important topic from not only the exam point of view, but real life scenario also. So managing IP traffic with access controllers, right? So these slides we can always have a look at, right? Look at this. Types of access controllers, right? We got standard as well as extended, right? If you configure standard, whenever a packet comes on the router, it's going to check only the source IP address and then permit or deny that packet. In case of extended, it will check all the four things, right? Source IP address, destination IP address, protocol, port number, and then it will either permit or deny the packet. I hope you like the demo, guys, right? Feel free to connect anytime. I'm readily available. I'm a freelance trainer, right? And you can contact me on this number, right? 9421410467. My name is Dhananjay Patankar. I have bases in Mumbai, Delhi, right? And I have got international training experience of total experience of 20 years, but I have had my trainings from right from USA, Canada, Australia, Hong Kong, Singapore, right? So that's it for now. I hope you like the video. Thank you so much and see you later on in my next video, right? Thank you. Bye-bye. Have a nice time. Wishing everyone all the best.